Hi, it's Mrs. Rubery, and today we're going to review expressions and equations. So first off, we're going to look at an expression. This is an algebraic expression because it's a combination of numbers, variables, and operation symbols. If you remember, we could classify parts of an expression and divide it into terms by separating it before any addition or subtraction symbol. So as you can see in this example, there's three terms. The 2x, then there's a plus sign that separates it from the next term, 4y. And the third term, there's a subtraction sign that separates it, that 9 is the last term. The other things that we learned about is that a number that's all by itself with no variable attached to it is called a constant. So in this example, the 9 is a constant. It's all by itself. The 2 and the 4 are called coefficients. Co means together to make it more efficient. So the 2 is next to the x. Instead of writing x plus x, we could say 2x. The 4 is the coefficient along with the variable y. Instead of saying y plus y plus y plus y, we can say 4y. So the 4 is the coefficient that's next to a variable. So let's do some examples. How many terms? So the first thing we want to do is make vertical lines before the plus or minus signs. So we can see in this example we have 4 terms. What are the coefficients? So coefficients are the number that goes with the variable. So it's pretty obvious here that we have a coefficient of a positive 2, but there's also an invisible coefficient right in front of that x, which would be a coefficient of 1. So our coefficients are 1 and 2. Remember, the coefficient is just the number part. And finally, what are the constants? Constants are numbers by themselves. So we have a -5 and a +8. And don't forget that the minus sign acts as a negative. So it's not just a 5, it's a -5 and an 8. All right, in our next example, I've included parentheses to remind you that we can't break up parentheses. So when we're dividing this into terms, we can put a line before that plus sign and a line before that minus sign because we can't break up the parentheses. That's one term. So how many terms? There are 3 terms. The coefficients, in this case, is just going to be the 6 because we're going to count this as one whole term. So the 2 is really not a coefficient in this example. So 6 is our coefficient. And our constant is going to be the number by itself, which would be the -8. All right, we're going to go next to translating algebraic expressions. So I have a bunch of key words on here that we've talked about earlier this year that represent addition, subtraction, multiplication, and division, and some key things about turnaround words. So if you see in a subtraction problem something like take away from or less than, remember that from and than are turnaround words which will switch the order in which you write the algebraic expression. Another thing to be on the lookout for would be parenthesis words, things like the quantity of, the sum of, the difference of. So here's 2 examples of 2 expressions that are super close to each other. So in the first expression on the left, I have a 2 times the difference of x and 5. So there's a 2 parentheses x minus 5. There's a couple different ways we could say that. I could say double means multiply by 2, the difference of x and 5. I could say 2 times the difference of 5 taken away from x. Now see, the from word switched around the order of the 5 and the x. And for that same expression, I could see double the difference of 5 less than x. Again, turnaround word. For the expression on the right, I have no parentheses. So this one doesn't have any difference of parenthesis words in the written expression. So it'd be more like double x decreased by 5, 2 times x minus 5, and then 2 turnaround examples, 5 taken away from double x, or 5 less than 2 times x. All right, let's try some examples and a time to climb. So our first question, twice a number increased by 5. So we have to decide if there's parentheses or not. I don't see anything about sum of, just twice a number increased by 5 would give me that choice there, 2x plus 5. Question number 2. Double the sum of a number in 5. Now I see the words sum of, which are parenthesis words. So this one would be 2 multiplied by the sum of, parentheses, x plus 5. Question 3. 5 less than triple a number. All right, I see less than means subtraction, and than is a turnaround word, which means the 5 is going to go to the end, and the triple a number, 3 times the number, goes to the front. So don't forget about our turnaround words. Question 4. Half of a number decreased by 8. So if I take half of a number, I'm either multiplying the number by 1/2 or dividing it by 2. Decreased by 8, there's no turnaround. So it's going to be 1/2 x minus 8. Question 5. 7 times the difference of a number taken from 9. There's a bunch of stuff in there. Difference of means we're going to have parentheses. A number taken from 9 means the 9 comes before the n. All right, let's talk about simplifying expressions. So yesterday when we worked with the distributive property, we reviewed how to distribute. If there's something with parentheses in your expression, we need to distribute first and then combine like terms. So take a look at this example. I first distributed the 4 and turned it into 2 terms, 12x plus 8. And then in the second part, I distributed the 2 and got 2x minus 6. Now that I have 4 terms, I can start combining them. A 12x and a 2x make 14x's. And the constants 8 minus 6 make 2. So let's try this example. So the first thing I'm going to do is distribute. And that gives me 2y plus 6x. Copy down the rest of the terms that are before and after it. And I like to separate this into terms for myself and then use different colors to find the like terms. So I have a 6x minus a 4x would make 2x's, plus 6 more x's would make 8x. And then for my other like terms, I have a 2y and a y by itself, which is 1y. So 2y plus 1y make 3 y's. Let's try another example. I'm going to distribute first. And I get 15 plus 6x. Copy down the rest of the terms. Separate the terms before the adding or subtracting symbols. And now look for like terms. I have a 4x plus a 6x make 10x. Minus 3x makes 7x. And then we have a 15 as a constant plus 2 makes 17. All right, now we're moving on to expressions where we need to evaluate. Evaluate means plug in the value and solve using order of operations. So let's evaluate this for x equals 3. So anytime I see an x, I'm going to plug in a 3 and just copy down my new expression. Remember, when a number is next to a variable, it means multiply. I'm going to follow my order of operations and do parentheses first, and I get 9. Copy down the rest of my problem. I now need to do my exponents. I get 81. Copy down the rest. Done with parentheses and exponents, I need to multiply or divide whatever comes first. I get a 6. And almost done here. I need to add or subtract whatever comes first. So I'm going to subtract, and I get a 75 plus 5 gives me a sum of 80. So we're just taking two different things, expressions, plugging in a number, and then following our order of operations. All right, on to equations. So for equations, there's 3 simple rules for solving every equation. I need to isolate the variable, get it by itself, use inverse operations, and keep it balanced. Let's practice how we do that. All right, let's take a look at the first problem. So I have 8 equals 4x. What am I going to do to solve it? I need to get the x by itself. It's next to a 4, which means it's being multiplied. So the inverse operation of multiplying would be dividing. So I need to divide both sides by 4 to isolate the variable. Question number 2. X minus 4 equals 9. So this one, the 4 is being subtracted from the x, so I need to isolate the x by getting rid of a minus 4. To do that, I would add 4 to both sides. Okay, question number 3. 13 equals x plus 4. If I need to isolate the x, there's a 4 being added to it, so I need to subtract 4 from both sides. Okay, and in this one, I have x divided by 4, so in this, I need to multiply both sides by 4. Isolate the variable by using inverse operations and make sure I keep it balanced by doing the same thing to both sides. All right, so a couple to solve. I'm going to subtract 7 from both sides. I show it like that. Put my big equal sign, and I'm left with 8 equals x. Next example is multiply. So to isolate that variable, I'm going to divide both sides by 4, and I'm left with d equals 8. Okay, in this equation, c is getting subtracted by 9. So to get rid of the minus 9, I'm going to add 9 to both sides, and I'm left with c equals 20. And in this problem, I'm having x being divided by 5, so I need to multiply both sides by 5, which gives me 30 equals x. And that concludes our lesson.